Okay, so today we are going to look at measures of variation. And the first measure of variation that I want to take a look at is the standard deviation, okay? Now, in order to define the standard deviation, the first thing I want to do is define what a deviation is. And here I have the definition of a deviation. Given an individual data value, xi, so that's the original data from our set. This is a raw data value, xi. The deviation of xi from the mean is just the difference of xi and the mean. So basically, the deviation for each individual data value xi, we have all our xi's, the deviation is just going to be xi minus x bar. So the deviation is just what we get when we subtract xi and x bar from each other. So xi minus x bar, this is what we're going to be calling from now on the deviation, or the deviation of xi from the mean. All right? So once we know what a deviation is, the next step is to define the standard deviation. So the standard deviation of a set of sample values, which we denote by the letter S. So whenever you see the letter S, we are talking about the standard deviation. And the standard deviation is a measure of variation of values about the mean. It is a type of average deviation. I want you to pay attention to that. It's an average deviation from the mean. So what we had on the last slide was a definition of the deviation from the mean. The deviation from the mean is just each individual data value minus the mean. Well, what we have here is the standard deviation is just an average of those things. So basically, what we want to do to find a standard deviation is find all of the deviations from the mean by just subtracting each data value from the mean. And then once we found that, we're going to find some way of averaging it. Well, the way that we average it is going to be kind of weird. This is the formula that we have for S. The standard deviation of a data set is what you get when you first find all of the deviations. So we're going to take each x value and we're going to subtract from it x bar. So we first find all the deviations by subtracting all the xi's and x bars. Once we do that, we're going to do something strange. We're going to take all those deviations and we're going to square them. So we have a bunch of deviations. Depending on the size of your data set, you have n deviations that you calculate for each individual data value. And then you're going to take each of those individual data values and you're going to raise them to the second power, multiply them by themselves. All right? Then once you do that, you're going to take all those squared deviations. We have the deviations and we square them, right? We're going to take all those squared deviations and we are going to sum them or add them up. So we take the deviations, we square them, and then we add all those values up. Once we've added them all up, we're going to divide, just like we do when we are doing an average. We add up and divide, but in this case, the average, we're not going to divide by n as you would think. We're going to divide by n minus 1, which makes this a little bit weird as an average. We're not dividing by n, we're dividing by n minus 1. And then, in order to take care of the fact that we squared all those deviations, to scale it back down, we're going to take the square root of this entire thing. So this is the formula for the standard deviation of a data set. It's the square root of the sum of the square deviations over n minus 1. All right? So let's go ahead and take this formula and actually calculate the standard deviation for a data set. Now let's see. Which data set do I want to use? I know. If you ever have been to the site NBA.com, on NBA.com you can actually find a lot of things. You can find, for instance, player stats. Here we are on NBA.com. You see we're on the NBA website. And on NBA.com, I'm going to look at the stats for LeBron James. And let's see. LeBron James, that's my favorite team. It's the Heat. Not my favorite player, but he is playing on my favorite team. Anyway, what we're going to do is we're going to scroll down here to look at some of LeBron's stats. Here are LeBron's stats for the 2013 season. And if you notice, here, actually this is the 2012-2013 season. If you notice, in January 2013, we have all the point outputs for LeBron's 13 games that he played right here. So those 13 values I'm going to turn into a data set. And we could look at this in two ways. We could look at this as the population of all the games he played in January 2013. In that case, this would be a population. Or we could look at it as a sample from all the games he's played this year. This sample would be taken just from the month of January. So since we are doing the sample standard deviation, we're going to take January as a sample of his point output this year. So we're going to put all these data values into a set. So we have here LeBron's point output for the month of January. These are the 13 games he played in January, and this represents how many points he scored in each game. The first thing we want to do is we want to find the average X bar. So X bar, let me see. We had a video before that told us how to find X bar. We said that X bar, the mean of a data set, was equal to the sum of the xi's over n. In our case, that's going to equal, well, if you add up all those data values, you get 351 if you add all those numbers up. And if you divide them by the total number, which is 13, we get that X bar is actually equal to 27. So there we have the average. We have the mean for our data set. So since we have the mean for our data set, the next thing we want to do is we want to go ahead and we want to find all these square deviation or these deviations. So we're going to go ahead and find the deviations here. Well, the first one is going to be the deviation of 32, the first data point from the mean. That's going to be 32 minus 27, which is equal to 5. So the first deviation from the mean is equal to 5. And I'm just going to go through and find all the rest of them here. We have 5, then 27 or 30 minus 27 is 3. We have 24 minus 27. Well, that's actually negative, right? 24 minus 27 is actually negative 3. And then we're going to go through and we're going to do this for all of the data values. So we get, let's see, negative 5, negative 12, negative 7, negative 5, negative 12, negative 7. Those are those deviations. We have 5, negative 2, and 12. 5, negative 2, negative 2, negative 2, and 12. And let's see, we have 4, negative 4, 7, 4, negative 4, and 7. And we have negative 3. So this column is the representation of my deviations. Basically, this column is the representation of my xi minus x bar, because we found x bar over here on the side to be 27, and each of these individual data points is the individual xi value. So each xi has its own deviation from the mean, and this is a list of all the deviations for the mean for all of the xi. The next thing we want to do is we want to square those deviations. So you see the next column, we have the squared deviations, which is xi minus x bar squared. So we're going to take these deviations and we're going to square them. So we're going to square all of our deviations. The first deviation is 5. If I square that, I get 25. The next deviation is 3. If I square 3, I get 9. The next deviation is negative 3. If I square that, I also get 9. Squaring the negative 5, I get 25. Squaring the 12, I get 144. Squaring 7, I get 49. And squaring 5, I get 25 again. Square the 2, and I get negative 2, and I get 4. Square the 12, I get 144. Square the 4, and I get 16. Square the negative 4, I also get 16. Squaring 7, we get 49. And when you square negative 3, you get 9. So there I found all my squared deviations. So the next thing I want to do after I found the squared deviations is, well, the next thing I did when I gave you the formula was after I found the squared deviations, I added them all up. So what I'm going to do next is I'm going to take this column of squared deviations here, and I'm just going to add all those data values. Okay, it turns out that the sum of the squared deviations, if you take this column and add it up, let's write that here, the sum of the squared deviations of the xi minus x bar squared. So you see this column represents my xi minus x bar squareds, and I put the sum symbol, this sigma, in front of it, which means I'm adding all of those up. So the sum of my squared deviations turns out to be the number 524. So if you add that column up, you get 524. So that's the sum of my squared deviations. That's the number I need. That's one of the numbers I need, okay? If you remember, this data set was for 13 games. So I have the sum of my squared deviations. The only other thing in that formula other than the sum of the squared deviations is the fact that we're dividing by n minus 1. In our case, n is equal to the sample size, which is the number of games he played in January, 13. And let's see, the last step now is to actually calculate my standard deviation. So let's start here. We have all the information we need. The standard deviation, it says, is equal to the square root of the sum of the squared deviations, the sum of the deviations, which are the xi minus x bar squareds, all divided by n minus 1. So I have all this information. Let's just plug it in. This is then equal to the square root. Well, the sum of the squared deviations, the numerator of this fraction here, the sum of the squared deviations, is what we went through that table to find. That number is 524. And in the denominator, we have n minus 1, which is 13 minus 1. So let's see what we get here. We get the square root of 524 over 12. And let's see what that gives us. So let's bring out our trusty TI-83 calculator and see if we can calculate that value. Turning it on. Oops, I have values here already. Let's see. We have the square root, so I'll take the square root, second square root. And I'm taking the square root of 524 over 12. Close parenthesis, and we will get the standard deviation of this data set is equal to, oops, disappeared. What do we get? Okay, now let's talk about rounding actually. You see this decimal number that we get is a quite large decimal number. In order to round this number so that we match up our answers with the answers that we would see in the back of the book or the answers that Triola, our author, would give, what we want to do is we want to round it so that there's one more decimal place than was present in the original data set. Now, because the original data set contained just point totals, which were whole numbers, we're just going to round to the tens place. So we're just going to round this to the first place after the decimal, and we're going to say that the standard deviation for this data set is 6.6. So the average deviation of LeBron James's points per game is going to be 6.6 points. So there you have it. We've calculated our first standard deviation.